some of the stuff that Jim Bowes, Chris Castiglione, and Rich and Mike Thomas and Megan talked about with some of the assessments that we're doing in the corridor, specifically for fish spawning and nursery habitat. So I want to thank and acknowledge my team of co-authors here. It's always a privilege to represent all these fine scientists. So I thank them for their efforts pulling together a pretty impressive slideshow with a lot of data that we're summarizing. So kind of building on what Rich just talked about, we're doing the monitoring work in the corridor for a bunch of different reasons. The first is to find out what species of fish are in the system, using the various habitats to spawn, how well are those habitats functioning, and use those data to identify opportunities for restoration. So to follow up the restoration, we have built a number of fish spawning reefs in the system that Jim mentioned earlier. And we're also looking at the production of fish off those reefs, as well as other areas within the corridor with these larval fishes and juveniles that are moving through the system to assess the use of the system and its value as nursery habitat. And to get a closer look at that, we've been sampling zooplankton and looking at some of the diets of the larval fishes in the system, as well as doing some biophysical modeling to look at connectivity issues. We really haven't described the system in detail today. There's a great paper by my colleague Daryl Hondorp in Journal of Great Lakes Research in 2014 that really talks about the physical attributes of the corridor and why it's a very unique system in the Great Lakes as well as globally. First is its enormous magnitude of water. It's 5,300 cubic meters of water a second moving through the system. That's very stable. The hydrograph on this is pretty stable throughout the year. So there's no flashiness like you see in like the Mississippi or Missouri rivers. It's unimpeded. There are no dams or locks on this system, so it's kind of a unique resource. The other connecting channels in the Great Lakes all have water control measures on them that kind of impede fish movements through the Great Lakes. As Jim and Rich and others mentioned earlier, there's been a widespread, long history of degradation to habitats in here. So it's a prime opportunity for restoration. The work we did here, you can see our sample design here in the St. Clair. We have larval fish and fish egg mat sample sites throughout the system. We also did a couple of years of nursery habitat work in the Delta with our colleague up at Central Michigan University, Scott McNaught, and one of his students. Same thing in the Detroit River, kind of a really intensive, extensive blitz of surveys to see what fish are in the system, what habitats are using, what's the magnitude and the extent of spawning, and what kind of larval production are we getting out of there. So we're basically focused on the early life history stages and also the adult stages. So the Fish and Wildlife Service, Justin and Jim have done quite a bit of gill netting over the last decade to identify what species are in the system at different times of year for spawning. On the left here we have a fall gill net survey in both rivers looking for spawning lake whitefish. We've found none in the St. Clair River to date. However, the Detroit River, we've captured them both at Fighting Island up near Fort Wayne, and we seem to intercept them quite regularly as they're coming into the river down here in Lake Erie. So we are finding lake whitefish moving into the Detroit River to spawn in the fall. Our egg data, these are walleye gill net data here again. Catch per effort in the St. Clair River is about 1/10 of a fish per hour of gill netting. And in the Detroit River, most of the gill netting has occurred in the middle part of the river around Fighting Island, Fort Wayne area, and quite a bit higher catch rate for adult walleye in the springtime there. Moving back to the whitefish, these are egg data. In the St. Clair River, we've been putting egg mats on the bottom in the fall to look for evidence of spawning by catching the eggs. We did catch a couple of eggs in 1 year in the middle of the St. Clair River. However, the Detroit River, it's orders of magnitude more eggs there. We've been seeing the fish use habitats all the way from Belle Isle up near Lake St. Clair right on down through the lower channels of the river. I'm going to show a series of graphs that all kind of follow that egg map and these larval fish abundance graphs. So on the left side here is the log transformed density in terms of numbers of larvae per cubic meter, and the x-axis is the month. So we kind of have our catch per effort, our standard catch density plotted, and we broke these data down into the main channel of the St. Clair River, the delta distributaries like the North Channel, Middle Channel, as well as out in the mouth in Lake St. Clair itself. So what I want to point out here is it's a pretty low catch of larval lake whitefish in the St. Clair River. We do get some fish later in the season in middle and late summer, and we think that almost all of these fish are probably coming down from Lake Huron, given that we found only a couple of eggs in the system and no evidence of adults in the system to this date. The Detroit River larval lake whitefish abundance is quite a bit higher, a couple orders of magnitude higher. Typically, we get these guys early in the spring, beginning in March. As soon as we can get on the water, they seem to have hatched, and they progress out through the spring. Pretty stable as far as total densities over time. And these data here we've broken down into 4 parts of the river: the upper river, middle river, lower river, and out in the mouth of Lake Erie. So one of the questions we had when we started this larval work about 9 years ago was, when these larvae come out of the river, where do they go out in the lake? Are they meeting up, getting connected to what we would consider favorable nursery habitats in the nearshore zone? Or are they just being injected into the deep offshore areas of the lake where we think that nursery habitat is poorer? So we've enlisted Mark Dufour. He's a PhD candidate down at University of Toledo who's a really good Bayesian statistician, and he developed a model using our larval fish catches in these different distributaries at the mouth of the Detroit River, and calculated estimates of larval abundance coming out of each of these channels. So we have the Amherstburg, Boblo, Livingstone, Sugar Island Cut, and the Trenton Channel, where we've sampled repeatedly over time, over years. Here I have the 3 recent years of data. On these graphs we have those same channels represented. The blue bar here is the relative magnitude of flow coming out of those channels. So Amherstburg has the most discharge of any of these channels, followed by Livingstone and the Trenton Channel, and then Boblo and Sugar Island Cut have less water coming out of them. So what Mark did is calculate the relative number of larval whitefish, in this case coming out of those different channels. These are represented in millions of larvae coming out in the spring of these years. A lot of things we could talk about here, but just generally the Amherstburg channel seemed to repeatedly be most consistent in producing the most whitefish larvae, or having them discharged through that channel, followed by the Livingstone and the Trenton, and then the Boblo and the Sugar Island Cut were even fewer. So there was a direct relationship or a correlation with discharge and the numbers of larvae coming out of those channels. So I'm going to show this again for walleye and yellow perch, but I'm not going to explain it in that much detail. So here we have our walleye egg collections, numbers of eggs on the egg mats. Pretty extensive sampling in the St. Clair River, all the way from Port Huron on down through some of the channels in the Delta. The green dots represent catches, and the larger the green dot means the more eggs, as you can see on the legend over here. So we are getting quite a few eggs in the St. Clair River, but not in real high densities anywhere. In contrast, the Detroit River, we're getting eggs pretty much every place we sample, and we're getting orders of magnitude higher egg densities on these egg mats in the Detroit River. And as many of you know and fish down there like I do, it's starting to kick in right now. So as far as the walleye spawning and the catches. These are larval walleye abundances in the St. Clair River over the last 4 years. Notice that these are in May and June is when we're catching these, and that's because it's colder up there. We're getting that large amount of cold water coming out of Lake Huron, so the spawning occurs a little later, the hatch is a little later than what we see in the Detroit River. And the densities here are low, you know, compared to what we're going to see in the Detroit River. So we got higher densities occurring throughout the river in the Detroit, as well as it occurring just a little bit earlier than the St. Clair due to the warming effect of Lake St. Clair contributing to the warming of the Detroit waters. Here's that same picture again for walleye and coming out of these different distributary channels. There doesn't seem to be as strong a correlation here with the channel discharge and the abundance of walleye across these 3 years. We actually have about 9 good years of data from these sites here that we're going to be incorporating into this Bayesian model to kind of tease out if there are repeatable patterns and how that may be influenced by spawning habitat upstream. Yellow perch in the St. Clair River, we do see quite a few larvae. We don't collect their eggs. They don't broadcast spawn like walleye and whitefish do. But there seems to be quite a few larvae coming down the river in every year that we've sampled there. Again, these are a little later in the year, typically peaking in late May through early July. In the Detroit River, a lot of these fish, they're found throughout the river. A lot of them we think come out of Lake St. Clair and drift out down through the river out into Lake Erie. A little higher magnitude on yellow perch abundance in the Detroit River than the St. Clair. And there seems to be a relationship between the discharge in the distributaries and their abundance. Amherstburg, Livingstone, and Trenton seem to have the most larval yellow perch coming out compared to the channels that have less water in them, which I guess makes logical sense. Our zooplankton survey, we really just began a standardized approach to this a couple of years ago when Kevin Keeler came on board our team. So we're sampling from the upper St. Clair River down through Lake St. Clair, a couple of sites, right out into Lake Erie, using standard EPA protocol. Just a real general summary of what we're seeing here in the St. Clair River early in the year, in the spring. The community is dominated by calanoid copepods, probably a signature of the Lake Huron zooplankton community. By summer, we're seeing more cladocerans in the system. These are also probably coming out of Lake Huron, as well as some production in the tributaries and small bays within the river itself. Detroit River seems to look a lot more like you would think Lake St. Clair looks. More cyclopoid copepods in the spring, and then that shifts over to cladocerans later in the summer. So we've taken these zooplankton data and we wanted to look and compare what's in the zooplankton community with what some of these larval fishes are eating. So we got invited to give a paper at the recent Burbot conference. And we didn't make the conference, but we did get the paper done and submitted, and it's in press right now for these burbot larvae. We caught all these guys up in the St. Clair River in both our pelagic gear and our benthic D-frame nets that Jim talked about earlier. They are eating zooplankton in relatively good numbers. This is the proportion of the different categories or prey types in the diet in terms of count and biomass. What does happen is these larger burbot larvae, about 15 millimeters and larger, seem to switch over to macroinvertebrates, just like night and day, turning the switch on and off. So the smaller fish, 5 to 10 millimeters on up to 15 millimeters, focused on these zooplankton items, but once they were bigger than 15 millimeters, we did observe an ontogenetic diet shift, and they started crunching macroinvertebrates. So to conclude here, this was a real quick whirlwind tour of our egg and larval data set and some of the adult work that the Fish and Wildlife Service has done. We are seeing widespread spawning in both systems by walleye, yellow perch, and a host of other native species that I didn't talk about here today. In general, the Detroit River is higher in productivity for spawning and larvae than the St. Clair. As Jim pointed out, the artificial reefs are being used and are providing habitat for spawning lake sturgeon as well as whitefish, walleye, and native suckers. The zooplankton community appears to be adequate for nursery habitat, and the fish are using it. They're feeding on the plankton community and invertebrates in the system. They're growing, and some of our early modeling work here suggests that they are connecting to functional nursery habitats. We have a few papers out there right now and more in progress that are going to take closer looks at all of these different issues, and some focus on biophysical modeling of the larvae coming out into Lake Erie and looking at the relative contributions of the Detroit St. Clair River walleye stocks compared to the Maumee, Sandusky, and reef stock in a portfolio analysis that Mark Dufour and some others have written up. And we are fortunate to have GLRI funding that'll get us through a couple more years of this intensive assessment. And our plan is to take all of this intensive work, run it through a sieve and a filter, and come up with the monitoring program that Rich talked about earlier that helps keep our finger on the pulse of the fisheries and the other aquatic habitats in the system. So this is just the tip of the iceberg on what we have here really as far as our data set goes, and just wanted to give a quick snapshot of what we've been up to. So thank you very much for your attention.